morning, everyone. So we are picking up where we left off last class. So we're using substitution to find the point of intersection between two lines. We're looking for the one point that they have in common, that intersection point. So we are going to do questions 13 and 14 together, and then you will try 15 and 16 on your own. So we're on page 14 of our packet, and we're going to start with question 13. So remember, to use substitution, you need one equation to either be y equals or x equals. I see that my second equation is y equals 2x minus 1. So because I have y equals, I'm going to take my 2x minus 1 and I'll plug it in for y in the other equation. So I'm going to rewrite that first equation, but I'm going to leave the y out. So I'm going to rewrite it exactly how I see it, 4x plus 3, and then instead of times y, I'm going to replace it with 2x minus 1. Substitute that in for y. And then don't forget the equals 27. From here, now that I only have x's in my equation, I can go ahead and solve for x. So I see the parentheses with the 3 on the outside, which tells me I need to distribute. So I'm going to rewrite the 4x because that's not being distributed. Then we will distribute 3 times 2x is plus 6x, and then 3 times negative 1 is minus 3. And then rewrite the rest, equals 27. From here, I see I have 4x plus 6x. They're both x's, so I can combine them. 4x plus 6x is 10x's minus 3 equals 27. So I need to get x alone. Always start with the addition or subtraction first. So to get rid of a minus 3, I'm going to add 3 to both sides. I get 10x. Negative 3 plus 3 is 0, so that's gone. And then 27 plus 3 is 30. Now I can go ahead and divide by 10 on both sides. And I get x equals 30 divided by 10, which is 3. Now remember, the solution is a point, the point of intersection. So we need both an x and a y coordinate in order to have a point. So now I can go back and find y. So I know that y is equal to 2x minus 1. 2 times my x coordinate minus 1. And I got that the x coordinate was 3, so I know that y is equal to 2 times 3 minus 1. 2 times 3 is 6 minus 1. And then, of course, 6 minus 1 is 5. So now that I have an x and a y, I can go ahead and write my solution point. The solution is going to be the point 3, 5, x, y. So if I were to graph these two equations, they would intersect right at 3, 5 on our graph. So if you need to write anything down, pause it, but we are moving on to question 14. Now remember, for question 14, in order to solve for the point of intersection using substitution, you either need to have x equals or y equals in your equation. I don't see that. I don't see x alone and I don't see y alone. They each have something else on that side, which means I need to solve one of my equations for x or y first. Now, it doesn't really matter which one you do, but I will take the top one and solve for x just because I see I have just an x there instead of the 3x down below. You could also solve the second equation for y. That would be relatively about the same level of difficulty as well. So if I take my first equation, x minus 2y equals negative 1, in order to get that x alone, I need to move the minus 2y to the opposite side. So I'm going to do the opposite and add 2y to both sides. When I do that, I get x equals, this is positive 2y minus 1. So now I know that I have x equals 2y minus 1. I also have the equation 3x plus y equals 11. And this first one I don't really need anymore because I rewrote it as x equals 2y minus 1. So I know that x is the same as 2y minus 1. I have x equals, so that's what I'm going to swap out in my other equation. So I'm going to rewrite this top equation, but instead of in x, 3 times x, I'm going to put 3 times 2y minus 1, since that's what x is. Then keep writing the rest, plus y equals 11. Now that we only have y's in our equation, we can go ahead and solve. I'm going to distribute the 3 first. 3 times 2y is 6y, and then 3 times negative 1 is minus 3. Bring down the rest, plus y equals 11. So now I'm going to combine like terms again. I have 6 y's and 1 y's, which is 7 y's total. Then, of course, the minus 3 equals 11. So I'm trying to get y alone, so I'll add 3 to both sides. And I get 7y equals 14. Then I want to get y alone, so divide both sides by 7. I get y equals 2. So that's my y coordinate, but I still need to find x. And I know from the equation that I rearranged that x is equal to 2y minus 1. I'm going to use that because it's already x equals. It's going to be a lot less solving for me. So instead of y, I'm going to substitute in 2 because I know that y is equal to 2. So I get x is equal to 2 times our y value, which is 2, minus 1. 2 times 2 is 4, minus 1. So I get x is 3. So that means my solution is the point 3, 2. Notice I wrote the x first and then the y. So pause if you need to write anything down for question 13 or 14. Next, you will try 15 and 16 on your own. Make sure the pictures you upload in Buzz show your work nice and clearly.